Hello everyone, I am Dattatray Nikam. Welcome you all on our channel eFunda. New day, new topic. And our today's topic is technical bid proposal guideline for instrumentation discipline. And if you are new to our channel, then please visit to our channel eFunda and watch all the videos created related to the various topics of engineering, fundamentals, instrumentation and control engineering, deliverables, telecommunication engineering, procurement engineering, and many others. And don't forget to subscribe to our channel to get latest notification on upload of our new video on our channel eFunda. So let's begin with our today's topic, that is a technical bid proposal guideline for instrumentation discipline. So far on our channel eFunda, we have created various videos related to the various topics, and now our today's topic is little different, where one will understand that how the projects are being bid by the organization and what are those proposals, basis or assumptions for any of the project, as this will give you the idea how the project is being proposed or being quoted, and accordingly the required deliverables or the design details being carried out by the organization. So let's continue with our today's topic, that is introduction to bid proposal. Now here we will see what is meaning of the bid proposal. A bid proposal is a document that companies use to outline the product or services, pricing and time frame they can offer to the clients for completing a specific project task. Second, what is the difference between bid and a proposal? A bid is a more detailed than an estimate and a quote, as it requires thorough knowledge of the timelines and the cost of a project, whereas a proposal is a more specific than a bid, and it is used when a business needs to get into a partnership with another business. Now we will see what is general content of any technical proposal. First is the executive summary, second table of content, third technical background where identification of the problem, justification for the proposed work, fourth technical approach, that is objective, basis and assumption, statement of a work including project task, project schedule, estimated cost. Fifth, capabilities, project team and key personnel, equipment and facilities. Sixth, anticipated benefit of the proposed work. 7, anticipated environmental impact of a proposed work. 8, nomenclature, definitions and abbreviation. Next, where is the references, previous project experience list, proven track record, that is PTR, and the last important is this appendices, where multidiscipline software requirement is exclusively covered. This is what the introduction of the bid proposal. Further in this video, we will see more details related to the proposal and their technical content and what are all the basis is being considered by any of the organization where instrumentation work is being carried out. Moving on to the fundamentals of technical bid proposal guidelines for instrumentation work. First, while preparing any technical proposal, correct understanding of a project scope description, technical clarification with respect to scope and associated requirements from client, detail of execution plan, estimation basis and estimated cost, etc. are included. Second, writing correct basis and assumptions while making technical bid proposal. Third, estimated cost. Generally, all the technical proposal shall always contain technical information and estimated required manpower to execute said project scope and separate submission of a commercial bid, that is proposal cost. Simplified, complete bid proposal is equals to the technical bid with assumption and basis plus commercial bid. This is how the complete bid proposal is prepared and submitted. In our today's video, we are planning to cover or focus on the basic proposal guideline while preparing technical bid for proposal for instrumentation work, and maybe these guidelines will help you to understand and make winning bid proposal. We have seen what is bid, what is proposal, and fundamental guidelines for technical proposal. Now we are moving on to the important topic where we will see proposal guidelines for instrumentation work, as this is the important basis for quoting any of the project, where we will give you some of the tips which are being considered at the time of bid proposal where the details are not available, and this is a thumb rule used for industry where we are submitting instrumentation related works technical bid. During proposal of any project, please prepare some of the fundamental points as a guideline so as to make a correct technical proposal. Now we will see first point A. Study and review the contract document, that is ITB, in detail and prepare deviation or any clarification list with respect to some clarification required on the project scope. B. Field instruments, particularly identify the different types of instrument from PNIDs, such as first pressure transmitter PT with remote seal diaphragm along with their rating, DP transmitters, DP transmitter with remote seal diaphragm along with rating, pressure gauges, pressure switches, diaphragm type pressure gauges with rating, etc. Second, DP type flow transmitter, flow elements which includes orifice, venturi, nozzle, anubar, etc. in line with size and rating. Third, DP type level transmitter, displacer type level transmitter, level switches, level gauges with their ratings. Fourth, temperature transmitter, temperature element with thermowell flange size and rating, temperature gauges with thermowell flange size and the rating. Fifth, that is a control valve, that is a final control element with control valve and shutdown valve along with their line size and rating. Sixth, on-off valves with size, line size and rating. Analyzers and analyzer shelters if any required in the plant. 8. Pressure safety valves, breather valves with line and rating. 9. Purge instrument if required, any other inline instruments. These are the fundamentals while choosing the field instrument based on the PNIDs. With this identification, one will get the number of counts of each instrument related to flow, level, pressure, temperature and any other final elements if it's required. We have seen field instrument. Now next point is the C, control system, that is a DCS, PLC, SCADA, RTU, welded control panel or any other specific control panels are required as part of the bid proposal based on the instrument and control system indicated in the PNID. First, decide, study if given the control system configuration diagram for the project. Second, for the DCS system, one should particularly look for calculate IO count for closed loop, monitoring loop, digital input output with a specific attentions to the barriers and the relays, MCC interface, annunciator window and lamps, push buttons, serial interfaces, etc. from PNIDs. And third point is PLC system, for which we will consider and calculate the IO count for PLC system with specific attention to the barrier, relay, MCC interface, annunciator, windows and lamps, push button as well as the serial interface, etc. based on the PNIDs. Now fourth point, any other control system such as a machine monitoring system, gas detection monitoring, governor control system, anti-surge control system, local control panel, etc. are to be considered. Fifth, based on the satellite rack room, that is SRR, and control room, that is a CR, for system related point, power consumptions and field equipment analyzers such as the local control panel, etc. are to be considered, where power consumption and when 20% spare, inform the UPS load requirement to the electrical department so as to consider UPS estimation by the electrical department. Sixth, based on the tentative quantity of a panel, different cabinets operator station and auxiliary console and other accessories. Prepare, make the control room layout, decide and inform the tentative size of the satellite rack room and the control room to the other departments such as civil and piping department for their necessary estimations and bid proposals. The construction bill of material. First, prepare piping hookup BAQ. A. Identify the typical hookups which to prepare and calculate the required BAQ based on the number of instruments shown on the PNIDs. B. Identify impulse tube length based on our experience, or as a thumb rule, consider approximately 3 to 4 meter for pressure transmitter and 6 to 10 meter for flow and DP level instruments if close couple installation is required or followed during feed stage, that is similar to EOP hookup. That means on the line where the tapping is connected, on the same line that instrument will be mounted with the help of stanchion, that is called close couple. C. Consider the pipe strap for stanchion installation along with 1000 mm pipe length stanchion, that is the stand of the length is a 1000 mm, that is otherwise follow the company standard as a normal practice for any of the specific proposal based on the company's guideline. Second, junction boxes. The number of junction boxes to be decided based on the total field instrument quantity. A. Transmitter, E2P positioner, I2P converter, temperature element, etc. B. Digital input signal based on field, pressure switch, level switch, temperature switch, flow switch, limit switches and push button, etc. C. Digital output signal, that is MCC, solenoid valve, lamps, annunciator. D. Consider separate JBs for analog, digital input and digital output signal with a due consideration to IS and non-IS, voltage level with a spare as per the contract document, that is ITB, or typically 20% as per the company standard. Third point is the cables. For cables, A. The main cable length based on the number of JBs and direct run cable from satellite rack room, that is SRR, control room CR to the field instrument or equipment such as LCP, analyzer shelter, etc. And based on the tentative location in the field, one can decide the main cable length. B. Average length for the branch cable shall be in the range of 30 to 25 to 35 meter, considering the JBs are located in the vicinity of the instrument where the skids or the equipments are located. C. As per the project requirement, power supply cable with a proper size with a voltage drop of 5 volt to be considered as a proposal basis. D. Check the requirement of special cables like fiber optic, serial communication cable, etc. because estimation of type of cables and their specific length, particularly for the branch cable and main cable, which will decide the cost for the cables and laying of the activities. Fourth, cable trays. A. Main cable trays or duct quantity shall be decided based on the tentative duct tray layout drawing made for the particularly for this project specific scope during feed. B. Main cable tray size for number of cables running through the tray with 50% loading. That means 50% of the load will be considered for the laying of the main cable and remaining 50% will be kept as a spare. Still required for the main cable tray duct support shall not be considered as it's in civil scope of work. As per the company's standard practice, calculate the required steel and inform to the civil department for the appropriate quantity. C is the branch cable tray quantity shall be as follows. First 40% length shall be in 200 mm tray, that means 10 cable of one pair into 1.5 square mm. Second, the next 20% length in 100 mm tray, that is a 5 cables of one pair into 1.5 square mm. Third, that is a next 20% length in 50 mm tray, that is a 2 cable in one pair 1.5 square mm. Fourth, that is a 10% length in 50 mm tray, that is a one cable of one pair into 1.5 square mm. This is how the cable tray estimation is done. For example, we will consider 10,000 meter length. For that, we will see how the trays are being calculated. For first 4,000 meter cable length shall be in 200 mm tray, that is 400 meter. Second 2000 meter cable length in 100 mm tray, that is 400 meter. Third 2000 meter cable length in 50 mm cable tray, that is 1000 meter. Fourth 100 meter cable length in 50 mm tray, that is 1000. This is how the 9000 is completed, and the remaining cable shall be of a direct run or a main cable to the control room. Fifth point, where we will see instrument air manifold. This manifold is being used to supply the air supply to the various instruments. So decide the quantity based on the 10 instrument air consumption per manifold, with consideration of a required tube sizing, that is a 6 mm OD or a 12 mm OD based on the specification, and spare as per the contract document. If not given, then 20% as a default. Sixth, instrument air tube, where total instrument air tube quantity can be calculated based on the number of consumers into 20 to 35 meter of the tube length for particular instrument. 7. Now consider tube tray. Instrument air tube tray quantity shall be calculated based on the total length of the tube into 0.3. This will give you the total quantity requirement for the tube tray. 8. Structural steel. A stanchion pipe requirement for transmitter, gas detector, pressure switches. Calculate pipe and a base plate steel requirement, where one can see a stanchion where it will be base plate. On that one pipe will be mounted so as to mount the instrument. First point, stanchion support for platform, that is channel of 100 mm by 50 mm. Second, stanchion support on a column, that means this instrument will be mounted on the column with the help of stanchion. Consider angle of 50 mm into 50 mm by 6 thick. Third, final total steel required for stanchion is approximately 29 kg or 18 kg into the number of transmitter. So note for this consideration of the steel quantity, consider that 60% transmitters are installed on the platform with the help of base plate and stanchion, and remaining 40% on column. This is how one can cover the different types of installation where the different steel requirement is there, so that you can capture the steel as the required as a best BOQ. 8B, steel for JB installation. First, junction box support or a frame. The steel required for junction box frame is equals to JB frame, that is a angle mounted, angle of 50 by 50 and 5 mm thick, plus JB frame, that is a C type. One can see or one can recollect that the junction box mounted on a C channel frame, that is a C type, and the support required to have a installation on the column, that is calculated. Total steel required for JB frame is equals to the number of JB and approximately 58 kg. This 58 kg we have calculated and given based on the requirement of the angle and C type installation. Second point, steel required for JB on columns. The total steel required for JB on column, that is a number of JBs into 13 kg. Third point, steel for branch cable tray. Steel required for branch cable tray, that is a tray support, is equals to the length of the branch cable tray into 40.5 kg. That 0.5 kg, how it has come? 4.5 into 0.15 divided by 1.5, that is a support for which we have considered the angle. That is how it has been calculated. Fourth point, steel for impulse tube support. Steel required for the impulse tube support is equals to number of transmitters into 4.5, that is 4.5 into 1 kg for one particular type of this impulse tube support. Fifth, steel for air manifold, that is steel required is equals to the number of manifold into 4 kg, that is a 50 mm by 50 mm by 6 mm thick angle support is considered for air manifold. 6. Steel for instrument air tube support, that is the length of angle is equals to length of instrument air tube tray into 0.33 is the multiplying factor. This is how steel required for instrument air tube support. Steel required for air tube support is equals to total length of the angle into 4.5 kg, that is a 50 mm by 50 mm by 6 mm thick angle is being considered. Now, after considering all this, one has to consider the MCTs where our cables will be entering into the control room. For that point, multi-cable transit block based on the number of cables with 20% spare, decide the frame size, and accordingly different MCT blocks are required. One has to estimate based on the frame size, insert block type quantity based on the number of cables entering into the control room, and the spare block is consideration for the future cables in case if it is later added based on the modification or advancement or optimization of the process where some of the additional instruments installation is required. For those cables will be entering through the MCTs into the control room. I know this topic is little difficult and maybe our today's video length is a little more, but we don't want to compromise on the quality and the content of this, and this will help you to understand bid proposal. But one should visit to our channel eFunda and watch all the videos related to the various topic so that one can make the understanding to understand these basic proposal guidelines which we have presented for the instrumentation work. And keep watching our channel eFunda. With this, we are concluding on our today's topic, and you can find our channel details as follows. If you are new to our channel, that is our YouTube channel eFunda, then subscribe to our channel eFunda and don't forget to press bell icon to get latest notification of upload of our new video on our channel eFunda. Similarly, you can follow us on a Instagram page. Similarly, you can follow us on our Facebook page as well. And keep watching our channel eFunda for various topics related to engineering and a project. With this, we can assure you this will help you to better your understanding on engineering and a project topic. Keep watching our channel eFunda. Thanks. Watch our channel for new day, new topic.